Alright, so for the next video, what we're going to do is just take a look at a projectile problem in general, not a special situation, just you need to figure some stuff out and how you would go about doing that. So I'm just referring this to this as a general launch angle. So let's set up the situation here. So let's say a cow is launched from a castle and you are trying to figure out how far away from the castle this cow lands. So what might they tell you here? Well, you've got your castle, all right, and let's get a side view of it going on. Oops, here. So here's our castle. And we are going to say that the cow is launched from the castle with an initial velocity of, let's go with, say, 20 meters per second. Now, the important thing to also label here is going to be the angle at which this is launched. So I'm going to draw in kind of an x-axis to deal with here. And so what you might see in a problem is that it's launched at an angle of, say, 30 degrees above the horizontal, something like that. Nice, easy number to work with. And then the problem might tell you how far above the ground the castle wall is. So I don't know, we'll go with about, let's go with 30 meters. Tall castle. And they're asking how far away does the cow land from the base of the castle. So, okay, we've drawn our picture. Hopefully you recognize this is a projectile situation. And what we need to do now is start organizing some information. So I'm going to go ahead and actually forgot to put in a good number line here. Let's do that. So that'll be our 30 meters. And we will be looking for this distance away. That it lands, and sorry, it's a little late at night here. So it comes and lands over here. Okay, so that's what we're going to see going on here. So now let's go ahead and start organizing information. So once again, you have to remember, split things up, x-axis, y-axis, x initial, x final, v initial, v final, acceleration, time. Now, some of you might be going, well, do I need to put the acceleration since I know it's a projectile? And no, you don't. If you know that that acceleration is 0, great. Just go with it. Over here we've got y initial, y final, v initial, v final, acceleration, which you know is negative g. But if you leave that out too, once again, it's in the projectile formulas, you're good to go. And time is the one variable that's shared with between the x and the y-axis. The other thing to point out here is if we look at VO and V final, since there is no acceleration on the x-axis, those two values are always going to be the same thing. You're going to have a constant velocity on the x-axis. All right, now we know we'll make our x initial 0. X final is what we want to know. How far from the base of the cliff is it going to land? Y initial, well, we're starting 30 meters above the ground. That's our starting position. Is the cow going to go higher than 30 meters? Yes. It's being launched upwards. But when we talk about the beginning and ending of the problem, we just want to know, where's the cow at the beginning? Where's the cow at the end? And the final position for the cow is going to be down on the ground, which we call 0 meters. Now, they did give us an initial velocity in this problem. And so I suppose if I was sitting there in class with you right now, I'd probably say, is it okay if I just go and say, the initial velocity is 20 meters per second. So I'm going to put a 20 meters per second there and a 20 meters per second there. Good idea or not a good idea? I would probably say turn to the person next to you and talk about this. Hopefully you're thinking about it a little bit right now, and hopefully you're going, no, that's not the case, because if we look at that 20 meter per second, it's a vector that is pointed to the left and up. And if we're trying to look at things on the x-axis and the y-axis, oh yeah, we have to split that stuff up. So your first step here is going to be to take this velocity and what we're going to have to do, enlarge it a little bit, let's move some stuff here, get rid of that, get rid of that, get rid of that, and this is where we say, okay, which way is it going? Oh, left or right? Left. Up or down? Up. And what you're going to have to do is you're going to have to break this into a vector, into component vectors. And so you're going to have to figure out how much of this is I hat and how much of this is our j hat part of this. And so if you do sines and cosines, we're going to say sine 30 equals the opposite side over 20 meters per second. And then we're going to say cosine 30 is equal to the adjacent side over 20 meters per second. And I kind of glossed over this quickly, but the adjacent side is along the x-axis, so that's going to go next to my I hat. The opposite side of this right triangle is on the y-axis, so that's going to be my j hat component. And so we're going to have to do some quick calculations here. You're going to find, if you do this, multiply both sides by 20 meters per second, that the opposite side of this gives you a vector that's 10 meters per second long. Now let's not forget that once you do this, when you're breaking into components, if I have a velocity vector here, then these components need to be velocity vectors too. You can't take a velocity and break it down into something else. So I'm only breaking down into those velocity vectors. All right, and then we're going to do real quick. (20 cosine 30 degrees equal to). There we go. I'm going to hope that's not even right. Degrees. There we go. 10.8. Do I like that? I don't know if I trust it. Sorry, it's late at night, and I want to know if this works or not. could just ask you to do it, but that'd be hard. This is the worst video ever. Sorry. Okay. Jason's side, sorry for that delay, is 17.3 meters per second. So now that you've broken into the I hat and J hat components, you can go ahead and move those up to your table. One thing some of you might be wondering about right now is the fact that I did not make my I hat component of the vector negative. You say, well, it's going to the left. So, okay, you're right that technically we've been saying to the left is negative, but remember with projectiles, it's a little bit easier to say things going in along the horizontal axis or going in the positive direction, because you'll never have it come back in the other direction if it's a projectile. So I'm just going to make going to the left the positive direction, and I'll denote that up there on my number line. Alright, so now that you have these bits of information, the problem hopefully becomes a little bit easier. So let's move that up, sorry. One thing I'm going to ask you right now is, can I say the final velocity is 0 because it hits the ground? Does the cow hit the ground, it stops, therefore final velocity is 0? Bad. No, because it's still moving right before it hits the ground. We don't know what that velocity is right before it hits the ground. Okay, now the fun part. If we want to get x final, that's what we're looking for, we're going to use x final equals x initial plus VOXT. And once again, we don't know what the time is, and we don't know what x final is. We have two unknowns. We're going to have to get the time. And like I said, 95% of projectile problems are going to require you to do two different steps. And so we're going to go to the y-axis again to get the time. And I start to write this out. Y final equals y initial plus VOYT minus 1/2 GT squared. Y final 0, y initial 30 meters plus VOY 10 meters per second times t minus 10, whoops, sorry, minus 5. I just multiplied 10 meters per second squared by 1/2 t squared. That's meters per second squared, and they're just being good about my units. And so if you go and try and solve this and you try and manipulate things around, you're going to have a heck of a time trying to do it. And in a lot of problems, maybe you can factor things out, do the FOIL method that you've learned in math class, but just as easy as any of that is, hey, this formula is a quadratic. What can you use to solve a quadratic? The quadratic formula. Well, does that mean you have to go through and do the whole quadratic formula by hand? You can, but I'm not expecting that, and I don't expect to see that on a test. For all I care, if you have a quadratic formula program on your calculator and you go in and you say, okay, A equals -5, B equals +10, ugh, and C equals +30, then great. Go ahead and use that because it's going to get you the correct answer for your time. So once you get that time, and let me throw it out there real quick. Let's see, I'm going to throw this into a program myself. Quadratic. Alright, so -5, 10, 30. So I get two solutions. I get one solution that says t equals -1.6 seconds, and another solution that says t equals 3.6 seconds. In math, there are two solutions because you're not necessarily describing some physical, actual thing. But here, we're describing an actual physical thing. You can't have a negative amount of time, so you know that this has to be the correct solution for time. It's going to take 3.6 seconds for that cow to travel from the castle to the brave British English knights below. So once you have the time, this isn't any different than the horizontal launch problem where, okay, I have the time, plug it in here, multiply by 17.3 meters per second, get your x, and we've simply got 17.3 multiplied by 3.6, and I get that they're about 62 meters away. So considering I just made up all those numbers and it's the 4th week of homecoming and I'm at school at 10:10 p.m., I'm feeling okay about things. Alright, so that's it for this one, and I will see you soon.